Work, energy and power. Question 3. The diagram below shows a heavy block of mass 100 kilograms sliding down a rough 25 degrees inclined plane. A constant force F is applied on the block parallel to the inclined plane as shown in the diagram below, so that the block slides down at a constant velocity. The magnitude of the kinetic frictional force Fk between the block and the surface of the inclined plane is 266 newtons. 3.1. Friction is a non-conservative force. What is meant by the term non-conservative force? Well, the term non-conservative force simply means that the force for which work done in moving an object between 2 points is path dependent, is a non-conservative force. 3.2. Elena states that the net work done on the block is greater than 0. 3.2.1. Is the learner correct? Answer only yes or no. Well, the learner is not correct, so we say no. Why? Explain the answer to question 3.2.1 using physics principles. Well, the learner is not correct because there is no acceleration. Because they told us that the object is moving at constant velocity. And if there is no acceleration, then F net is equal to 0 newtons, and therefore W net is also equal to 0. Remember the work energy theorem, which states that the total work done on an object is equal to the object's change in kinetic energy. Change in kinetic energy simply means that we have V final squared minus V initial squared. Now, if an object is moving at constant velocity, let's say the velocity of 5 meters per second, right? It's gonna be 5 meters per second squared minus 5 meters per second squared. And 5 meters per second squared minus 5 meters per second squared is equal to 0. And anything multiplied by 0 is 0. So W net is equal to 0. That's what they were asking. Question 3.3. Calculate the magnitude of the force F. Now we need to draw a free body diagram for this scenario. We have normal force, we have weight, we have force applied. Now remember, our object is sliding down, meaning friction is acting in this direction, not this direction, because our object is going this way. So friction opposes the motion of the object. Now let's break the components. We have weight perpendicular and we have weight parallel. So they're asking us to calculate this force. So we're going to use Newton's second law. F net is equal to ma. Now they told us that the object is moving at constant velocity, meaning there is no acceleration. So F net is equal to 0. Now we have force applied plus frictional force minus W parallel is equal to 0. Now we're going to transpose these two to this side so that we are only left with force applied. You're going to have weight parallel is mg sine theta minus Fk. The mass of our object is 100 kilograms times 9,8 sine of angle of inclination is 25 degrees minus the frictional force between the surface and our object is 266 newtons. 266 newtons. The answer is 5 minus 266. 148,17 newtons up the incline. If the block is released from rest, meaning the block was stationary without the force F being applied, it moves 3 meters down the inclined plane. 3.4. Calculate the speed of the block at the bottom of the inclined plane. What we have here is a right angle triangle, and we have our angle of 25 degrees, and we are looking for the height. Now they told us that the object will slide down a distance of 3 meters before reaching the ground. So in order for us to find height, we're going to use trigonometry. So now we are looking for opposite. So opposite, and we have hypotenuse. So we are going to use sine. Sine theta is equal to opposite over hypotenuse. Our opposite is height, and our hypotenuse is 3 meters. You're going to have sine theta is equal to height over 3. Sine theta is sine theta over 1. Height is going to multiply with 1, and sine theta is going to multiply with 3. So we're going to have 3 sine. What is our theta? Is 25 degrees is equal to height. So this is our height. Now, they told us that there's friction, right? So friction is a non-conservative force. So we're going to use the the work done by non-conservative force formula, which is change in kinetic energy plus change in potential energy. Now, when we expand this, we're going to have frictional force times delta x times cos theta is equal to half m v final squared minus v initial squared plus mg height final minus height initial. Now they told us the value of the frictional force, which is 266 times delta x is this, so it's 3 cos. Now friction is always opposing the motion of our object, so it is 180 degrees. The mass of our object is 100 kilograms. Now v final is the final velocity of our object when it reaches the ground, so we are looking for that. Now they said if the block is released from rest, meaning it was stationary, so v initial is 0 plus the mass of our object is 100 into 9,8. Height final is 0 meters above the ground, because that's on the ground. 0 minus, now our initial height is this height, so we're going to have 0 minus 3 sine of 25 degrees. Now when we plug this into our calculator, we get cos of 180 is equal to -1, so we have -798 is equal to 100 times half is 50 v final squared plus, when we plug this into our calculator, we get -1242,49769. When you transpose this to this side, we are going to get -798 plus 1242,49769 is equal to 50 v final squared. The sum of this is going to give us 444,49769 is equal to 50 v final squared. Divided by 50, divided by 50. This 50 is going to cancel this 50, and in order for us to get rid of the square, we're going to put the whole thing inside of a square root. Now our V final is equal to square root of answer divided by 50. Get 2.98 meters per second. That's the final answer. Thank you for watching.